In the early 18th century, European agriculture operated on a communal rhythm. Entire villages shared vast open fields, planting and harvesting by hand according to the strict dictates of the changing seasons. Then, landowners started building fences. Through a process known as the Enclosure Movement, they carved up these shared, ancient pastures into private, commercially managed plots. For commoners, this meant eviction from the lands their families had worked for generations. But for the wealthy landowners, these new enclosed farms became private laboratories for agricultural experimentation. Instead of scattering seeds by hand and hoping they took root, farmers deployed the mechanical seed drill. It dug a trench, dropped the seed at a specific depth, and covered it up in continuous mechanical motion. This area chart maps agricultural output. After centuries of stagnation, precise tools caused mid-1700s crop yields to shoot straight up. Overlaying the population line shows a direct correlation. More food meant plummeting infant mortality and a massive surge in the number of people. Farming became so efficient that it required fewer hands, even as there were far more mouths to feed. Millions of displaced rural workers had to look elsewhere for survival, driving a massive migration toward the emerging towns and cities. All those new citizens needed clothing. Displaced farmers crowded into early textile workshops, manually operating heavy spinning machines to meet this surging demand for fabric. Inventions like the spinning jenny and power loom multiplied the output of a single worker. Production shifted from a slow, domestic craft to a relentless, factory-driven process. But scaling up hit a physical wall. Heavy, high-speed wooden machines broke easily, and relying on water wheels meant factories had to be built on unpredictable rivers that froze in winter or dried up in summer. To build stronger infrastructure, engineers turned to metallurgy. Innovators developed coke-fired blast furnaces to forge iron and steel that could withstand the intense friction and stress of heavy industrial use. The energy problem required a different kind of engineering. By improving the design of the steam engine to minimize heat loss, Scottish engineer James Watt created a reliable power source that ran on coal, not water. Factories could now be built anywhere. Massive iron pistons converted pressurized steam into continuous rotary motion, driving dozens of machines simultaneously. With practically unlimited power and durable steel, manufacturers began churning out goods at a volume that completely overwhelmed the roads capable of carrying them. Factories were highly efficient, but the moment a product left the loading dock, it stalled. Millions of tons of finished textiles and iron goods were stuck on horse-drawn carts, navigating rutted, muddy paths. Civil engineers responded by carving up the landscape again. They laid down networks of hard-surfaced, weatherproof roads and dug thousands of miles of deep-water canals across the English countryside. The ultimate solution was to put the steam engine on wheels. The invention of the steam locomotive allowed massive cargo loads to travel over land at speeds previously considered impossible. Moving goods this fast meant that schedules, delays, and cargo orders had to be coordinated quicker than a human messenger could ride. The electrical telegraph solved this by translating letters into electrical pulses sent over copper wires. Connecting continents required insulating those copper wires against the crush of the ocean floor. Engineers wrapped the conductive core in dense layers of gutta-percha rubber, hemp, and steel armor to lay a functional communication line straight across the Atlantic. Iron rails moved the cargo, while telegraph wires moved the data. Isolated towns were now locked into a highly synchronized, high-speed commercial system. The system transformed the skyline. Urban centers swelled into dense hubs defined by endless rows of brick factories and a constant canopy of coal smoke. Down at street level, the reality was bleak. To maximize profit margins, owners paid subsistence wages, crowding families into claustrophobic slums and pushing thousands of women and children into dangerous machine work. The society fractured into a rigid binary. A concentrated new middle class of merchants and industrialists controlled the capital, while an expanding proletariat class survived strictly by selling their hourly labor. This map visualizes the resulting geopolitical shift. European factories consumed so much cotton, iron, and coal that nations aggressively expanded colonial empires to secure steady supplies and captive markets. Within decades, shipping lanes multiplied, linking a British mill directly to an Indian province or American port. A local effort by wealthy landowners to fence off their farms triggered a chain reaction. By solving one localized problem of agricultural efficiency, they set in motion the mechanization of labor, the division of modern social classes, and an entirely new, globally synchronized physical world.